Okay, here is section 4, section 1.4, example 4, so 1.4.4, and they just want us to solve this system. But notice this system has 6 unknowns. 4 m is 4, or number of rows is 4, number of unknowns n is 6, and so I don't want to do that by hand. And notice they don't show us either. They say here's the augmented matrix, which is row equivalent to this. Okay, well, we can perform that same magic. We can take the coefficients off of this, which are this, plus the right hand side to make the augmented matrix, and I did that in Sage. And so here I've defined the augmented matrix. There it is, just like what they had. And then I simply tell it, get the reduced row echelon form, assign that to B, and display those results of B. Now I could actually say show that thing, but I think it's a little better to break things up so we can see exactly what's going on with each statement. And so I hit evaluate and come down here, and there we go. I've got that same reduced row echelon form. And of course then we need to pull everything off, and so here's the x1, here's the x3, and here's the x6, x2, x4, and x5. So we would have x6 is equal to 1/4, x3 plus 1/3 x4 minus 2/3 x5 is equal to 5/3. We could take those two pieces and move them over to the right once we've written that out. And here we have x1 minus 3/2 x2 plus 11/6 x3 minus 19/6 x, oh, I missed one. So this is x1 minus 3/2 x2, 11/6 plus 11/6 x4, and then minus 19/6 x5 is equal to 1/24. And again, those variables that are arbitrary, the x2, the x4, and x5, we can move those over to the right hand side and just pick those as arbitrary elements. And so the only thing that wouldn't be arbitrary here is x6. It has to be 1/4, and that is the same solution they had. And here they go through and write those pieces down, and there we go. We have our reduced row echelon form from Sage. It was that simple, and we get our answers there. So that's example 4.